Thank you very much, Alan, for your gracious words. I will try to live up to them. I also like to thank Jan for inviting me to this intellectual banquet. What conference is there, that you can hear about galaxies and bacteria within a few hours of each other? I'm sure I've learned a tremendous amount. I'm not quite sure yet what I learned. That'll take some digestion and reflection, but it certainly has been extremely stimulating. Monday morning, there was a very enjoyable session exploring the hidden connections behind this conference. So let me just tell you very briefly how this outlier node gets connected to this very important network. So I see John sitting there. It was in the early 1960s. Okay, John Holland and I were freshly minted PhDs, and we co-taught a course, what probably is kind of a very early version of complexity science. It was called communication science. After that, I went to Berkeley, and for something like 3 decades, we lost contact. Then one day I was wandering around a bookstore on Telegraph Avenue in Berkeley, and I saw a book on the shelf there saying emergence. I've always been interested in the evolution of language, so a title like that certainly meant something to me. I took it down and looked, and the author was John H. Holland, and that rang a loud bell. So one thing led to another. John came to Hong Kong and spent some time with us, and it's partly a legacy from John's visit that we now have in Hong Kong something also in this general area. So the connection has been from Ann Arbor to Berkeley to Hong Kong to Singapore today. And John's legacy has been a new center established just a couple of months ago at the Chinese University of Hong Kong called Joint Research Center of Language and Human Complexity. It's distinctive in that it's collaborative among 3 universities: Chinese University, Peking University, and University System of Taiwan. Right? Unlike Hong Kong is always trying to catch up with Singapore, okay? And in this case, we don't dare to be this ambitious, okay? Martin Rees talked about very, very, very small things to very, very, very big things. And in the middle, of course, is us. So we will focus on human complexity, specifically in the area of language. And I hope that our interactions will increase as the research gets more and more results. So I like to begin with a picture. Yeah. I don't know very much about art, but I liked this picture, especially when somebody called to my attention what's scribbled over there in that corner. Here's a blow up. You can probably read this now. It's Gauguin asking 3 questions. Where do we come from? What are we? Notice he didn't say, who are we? What are we? What kind of being are we? And where are we going? So these fundamental questions require a multidisciplinary perspective, such as in complexity theory and in evolution theory. We share a very long evolutionary history with primates, especially the chimpanzees, our closest. This now works, huh? So I'm no longer tethered here. Especially the chimpanzee, our closest living relatives. Despite striking similarities, language has not emerged among chimpanzees, and they cannot be taught what we invented. Initial conditions for language emerged over 3 million years ago, leading to dexterous hands, bigger brain, cultural evolution which outstripped biological evolution, and of course, modern civilization. Linguistic diversity demonstrates the remarkable plasticity and power of our brain. We're the only species, okay, that communities cannot talk across to each other because of different languages. Okay? But we can learn different languages because of the plasticity of our brain. Different languages, in turn, sculpt the brain in different ways. How the brain makes language possible must be investigated in the context of linguistic diversity. The combination of brain and language is an answer to where we come from and what we are. So here's a good starting point. Sean Carroll in Nature about a decade back drew this tree, giving us an approximate timeline. And it can be simplified in terms of this lineage from mammals to primates, primates to Australopithecines, Australopithecines to Homo, the genus, up to Homo sapiens, our species. So according to this tree, we split off from the gorilla something like 8 million years ago. And we split off from the 2 species of chimpanzees something like 6-7 million years ago. After that split, there's been a tremendous variety of fossils which have been discovered. And for instance, there's a fossil over here called Australopithecus afarensis. Australopithecus afarensis at this level. These are fossils discovered in Afar in Ethiopia, so it's afarensis. And then various homos starting around 2 million years ago. Homo neanderthals, okay, went extinct, and we're the only surviving branch of this entire tree. The primatologist Frans de Waal wrote a very nice overview of what we learned about the chimpanzee from a century of research. And here, of course, is the grand lady of primatology, Jane Goodall. Here are some highlights. Wolfgang Köhler wrote a book called The Mentality of Apes, which showed that chimpanzees caged can use a branch to reach food, tool using. Jane Goodall's work in the field. Savage Rumbaugh's work with Kanzi, probably the most documented chimpanzee learning language. Tomasello in Leipzig and his group have recently written a whole bunch of things, including one in Science a few years back, advancing the cultural intelligence hypothesis, and another one recently on a particular design feature, pre-linguistic infants but not chimpanzees, can communicate about absent entities. The reason Duval talked about a century, because it actually can be traced back to a little-known Russian investigator called Nadia Coates, who actually lived with a chimpanzee in her Moscow apartment, okay, between 1913 and 1916. Did a tremendous amount of work on this chimpanzee, especially studying the chimpanzee's emotions. So in this, Nadia was influenced both by Pavlov, of course, and also by Darwin, who in 1870s wrote this book on the expression of emotion in man and animals. Chimpanzees, one of the few species besides us, can show self-awareness. If a chimpanzee falls asleep next to a mirror, you paint its ear. When it wakes up, it'll examine its ear in the mirror. Okay? Very few animals have that type of self-aware ability. Other animals collaborate. Here's two ants collaborating and moving something heavy, but this is something very simple and instinctive. Chimpanzees can collaborate too. This is in a European zoo, where the zookeeper has built a wire fence around the tree so that chimpanzees will not climb it and really strip off the bark and kill the tree. And here, two chimpanzees looking at all those delicious leaves there that they cannot climb up to get. So one chimpanzee got hold of a long tree branch. It's probably not too visible, but I think you can make out the outline. And here's that same chimpanzee holding up the tree branch, and his buddy goes up the tree to get those leaves. Okay? This is a type of shared intent, collaboration that's quite rare among other species. And of course, for several decades, people tried to teach the chimpanzee language. Here's one reported by David and Ann Primack at UC Santa Barbara. And Sarah was taught to communicate by putting chips on a magnetic board with respect to various articles that were the object of the discussion. So here are Sarah's language chips, okay? Including some verbs, including some adjectives, including some relationships like verbs. Same, different, no, not, and so on. If, then, question mark, and so on. But there's something rather significantly lacking in the chimpanzee. We can see here's a chimpanzee eyeing this banana, begging for it. On the other hand, if you put a bucket over the eye of the potential giver, the chimpanzee does not have enough of a theory of mind to realize that she cannot see the begging act. So the hypothesis that Esther Hellmann, who's a member of Tomasello's group in Leipzig, advocate, and I think correctly, is that although the chimpanzee, the orangutan, at comparable ages with the human infant, score quite well, quite similar to each other in the physical domain, they differ significantly, man and apes, in the social domain. So one way of sort of contrasting the linguistic ability or lack of linguistic ability of animal communication and human communication is to do what Charles Hockett did some years back when he wrote an article called The Origin of Speech, in which he outlined 13 what he called design features. We're the only ones that have a communication system that simultaneously has all 13 design features. So let's just take a little time looking at one of them. Let's look at number 10, which is displacement. Displacement is the ability to talk about things not here and now, but distant in time or distant in space. And to test this hypothesis, a group contrasted the behavior of a human infant, pre-linguistic, 12 months old, 12 months and some days old, and a chimpanzee, adult chimpanzee, several years, dozen years old, and so on. First, there's a requester, and then there's a giver. There's some commodities which are desired, like balls for the infant or fruit for the chimpanzee, and something not particularly desired. Okay? And two situations. One is that the subject is actually watching the transaction from the sidelines. And the other case, the subject is actually either doing the requesting directly or through a cage. So in as much as possible, comparable situations. And this is the result that they got. When the child points, okay, especially with the finger extended, this is, I want this, the child continues to point at the place where the desired object is, even when it's occluded from view. And the child, the infant, pre-linguistic infant, continues to point even when that place is empty, occluded versus absent. The chimpanzee, on the other hand, points a little bit less when it's occluded, but does not succeed in pointing at all in a focused way when it's absent. Okay. So this leads the investigators to conclude, overall, our main finding is that when a desired object was missing from the location in which other exemplars of that type of object had previously been placed, only the infants, not the chimpanzees, pointed to the currently empty location as a way of making the adult human understand their request for that type of object. Gee, that's a long sentence, but I think you know what they mean. Okay? It's the absence of this design feature of displacement in Hockett's term. Okay? So in reviewing the century of work, de Waal summarized by saying, a century of research on chimpanzees, both in their natural habitat, okay, that's field work, and in captivity, that's in a laboratory and in a zoo, has brought these apes socially, emotionally, and mentally much closer to us. Parallels and homologs between chimpanzee and human behavior range from tool technology, cultural learning, power politics, inter-community warfare. Okay? So de Waal emphasizes that there are all sorts of important similarities. At the same time, as we saw with respect to language, the chimpanzee is quite different, quite distant from us in having the type of communication system that we have. Why should this be? Well, I think one very obvious answer is in the brain. Okay. Here's something that was published in Trends in Neuroscience a few years back, in which the primates are plotted together in a tree with respect to their date of species differentiation, as well as with respect to their brain volume. So humans and chimpanzees diverged 5 to 7 million years ago. Very, very small genetic difference, but a huge difference in brain volume. In our case, our brain volumes ranges actually larger than that, from about 1,000 cc to about 2,000 cc's, whereas the chimpanzee's brain is a very small fraction of that size. Well, what brought about this difference? What were some phase transitions, as it were, that happened after we split? Well, I've always been quite impressed by this cartoon, okay? I don't know whether you can see very clearly these three ancestors of ours, okay, walked on all fours. They're quadrupedal. And somehow, this guy stood up. He said, hey, look, no hands. Just like a kid learning to ride a bicycle. He said, no. In this case, it's just regular locomotion. And this happened over 3 million years ago. When Australopithecus stood up 3.5 million years ago, actually more than 3.5, probably 3.7 or 3.8 million years ago, it set into motion a series of events that led to cultural evolution, language, modern civilization. I don't know whether this qualifies or not as a butterfly effect, but one wouldn't think that standing up would have all these very, very far-reaching, important ramifications. So around 2 million years ago, the hands, which became freed by standing up, started making stone tools. And step by step by step, the stone tools became more and more refined. First, just for pounding, and then for cutting, and then for scraping, and then for drilling. First, just stones, but then bones, ivory, and so on. So the advances in symbolic behavior is shown here in material culture. People differ a lot in when they prefer, what is their preferred date for language to have emerged. The very eminent American linguist by the name of Edward Sapir said language probably emerged pretty close to this time, when you must have some kind of an image of the tool that you want to make before you actually make it, kind of like a sculptor having an image of what he's going to produce before he strikes the first blow. Okay? So Ed Sapir dates the emergence of language way back. But of course, language is not an all or none thing. Okay? There's language of a certain type, language more sophisticated, language more powerful, language more nuanced, and so on. So this might be kind of a timeline, okay? So 3 million years more ago, erect posture took place. By the time stone tools were made, some kind of symbolic behavior was at place. Various other things happened in the meantime. And another very important phase transition was the invention of segmental phonology. By this I mean speaking in consonants and vowels instead of just prosody of duration, loudness, vowel quality. Okay? This greatly increases the rate of information transfer. And since we all have some kind of a limit to our immediate or working memory, the better you make use of that small time window, the more complex the message can be. So segmental phonology is another very important phase transition. So going back to the erect posture, okay, this is unusual in being a very complete set of fossils identified to be belonging to one individual. And that individual has been named Lucy. That is the Australopithecus afarensis that we saw earlier in the tree that Carol drew. And from this, by studying very carefully the various shapes of various bones, the pelvis, the leg bone, and so on, you can reconstruct a skeletal structure that is very consistent with the ability to walk. And luckily, we also have some other convergent evidence, not very far away from where Lucy was discovered. There were footprints dating that far back. These footprints were covered by volcanic ash. And removing the volcanic ash, they can study the pattern of indentation. And here's Mary Leakey, one of the famous paleoanthropologists, measuring the footprints. So I think by now there's general consensus that erect posture took place then. And the research, of course, continues to be made. Recently, they discovered another little bone that belongs to Australopithecus afarensis. And this was reported in Science a few years back. Plugging this in, and again, looking at the locomotion dynamics of Lucy's type. In addition to freeing up the hands to make tools, okay, which is a very important source of cultural stimulation, the whole head and neck structure changed. When we were quadrupedally, our face was down here. And this is essentially a straight tube. Once we stood up, the face migrated here, from here to here, and the tube, which used to be straight, is now bent. And this bent tube, this way, almost at right angles, is very important for phonetic versatility. And you can see some of the accidental residue of our earlier quadrupedal posture by seeing how certain nerves, okay, which go from the base of the brain to innervate the larynx, actually now is dragged down by the heart, which has descended. And here's another picture of this tube. And the best theory we now have about how we speak is that it has these several components, beginning with a power supply that's provided by the lungs. Okay? All these things are exaptations on earlier biological abilities. Okay? This power supply, which drives the speech, of course, is built on the earlier requirement of respiration. If we don't breathe, we die. Because we can breathe, we also learn to speak. Then there's another component which provides the oscillation vibration of the vocal folds. As I'm speaking to you now, my vocal folds are vibrating typically over 100 times per second, 100 hertz. Okay. And once you vibrate your vocal folds like this, you generate a family of harmonics which are decreasing in amplitude like this. This is what's produced. This is what's produced by phonation. And as the harmonics hit the throat and the mouth, resonances take place. I don't know whether this works. Right? Those are vowels. You don't hear them in one pulse like that. Those are vowels, and that's what that is. Okay? Depending on how I move my tongue, my jaw, my soft palate, and so on, I shape this tube differently so that it has different resonances. And today, because of time limitation, I'll primarily talk about just phonation. And that itself is already complicated and interesting. So the air comes up from the lungs and hits the vocal folds. The vocal folds are like that. Okay? When they're brought together, the air is blocked. When the air is sufficiently forceful, it blows them apart. Blows them apart, and because of the elasticity of the vocal folds, they fall back again, blow apart. Okay? If a woman is talking, this is happening at something like 200 times per second. It's very impressive. So here's the vocal folds when it's open, blown open. When it's shut, when it's 124 hertz. 1 octave higher, 174 hertz, about an octave higher, so on. So these are photographs taken by an endoscope stuck through the nose, posed over the larynx. The most amazing thing is that this rate of vibration can be exploited to make different words. And this is what we mean by a tone language. Okay? So there are thousands of tone languages in the world, but the most famous one, of course, is Chinese. We can exemplify these tones, which are just differences in rate of vibration, with these 9 Chinese characters. Cantonese says all 9 words differently. Mandarin, or Huayu in Singapore, okay, collapses some of them. They've merged into just 4 categories. These have collapsed, these have collapsed, these have collapsed, and so on. Okay. So, since I'm a native speaker of Putonghua, of Huayu, but not Cantonese, I'll just do the Putonghua for you, the Huayu for you. This will be shi, this will be shi, this will be shi, and these 3 are all the same. They're shi, 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 shi. Here it is, the actual fundamental frequency of the vocal folds as a function of time and vibration in Cantonese. You have tone 1, tone 2, tone 3, 5, 6, 7, and 8, and 9 are short ones because they're cut off by consonants like PTK. And here's a very impressive demonstration. Okay? To say 3, 4, 2, 0 in Cantonese, they're all level tones. Sam, se, yi, ling. Right? Now this is very, very demanding on your perceptual system. It's not only demanding because of the physical separation, even more so because people have different ranges. Okay? My low tone could be very close to a woman's high tone. Now, how do we distinguish these across speakers and things like that? And when I studied, when I ran into Cantonese, I thought, gee, this must be the world champion, okay, of tone systems. Until I read that in Mexico, in Oaxaca district, there's a language called Trique. And that actually has 5 levels. Here's an example of a Trique sentence. I will see bones is ku. Okay. These are in the opposite order that I'm used to. Usually I put 5 on top. But the people who transcribe these languages have 1 as the highest level. Highest level, lower, 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 lower. 5 distinct levels with 5 distinct words. And this is another way of representing them by plotting the frequency versus the slope of the contour. Some of you may know about this poem. It's written by, I wouldn't call it a poem, but it's a short essay by a long-term colleague of mine at Berkeley. His name was Zhao Yuanren. And the whole essay was written on 1 syllable, shi. So this is shi, 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 and so on. You can't do this unless you have tones. Even with tones, it's very difficult to understand, except if you speak Cantonese, then some of them are more distinctive, because here I coded in 3 colors, okay? Those which end in P's, those which end in T's, those which end in K's, and so on. I forgot. Your computer doesn't have the phonetic fonts that I have. So this is over just okay, I'll just simply explain this. So far, I've been telling you about tones distinguishing words. Here I have an example from a language called Yi that Professor Lapola is a world expert on, okay, in which the tone is actually used for distinguishing grammatical functions. So it's actually nga tsi ndu means I hit him. Nga tsi ndu means he hits me. The subject doesn't change, the object doesn't change. The verb defines who's the subject, who's the object by the tone. Yeah, that is you, right, Randy, right? Is this okay? Okay. I also want to point out that in this world of sound that we live in, there are 2 systems of sound which are especially important to us. One is the sound of speech. The other is the sound of music that we had a good treat of last night. Okay? And as early as 1871 in The Descent of Man, Darwin speculated that there must be all sorts of important evolutionary reasons for musical notes. And in fact, music is universal in our species and can be found in the archaeological record quite early. Flutes. Okay? Here's something found in Slovenia 50,000 years ago. Something found in France. In China, in Henan, in a place called Jiahu. Okay? A whole bunch of flutes we discovered, made from the leg of the crane, the crane's femur. And the amazing thing is, whereas these are kind of pretty well damaged by time, these are still playable. So there's an internet address that you could log on to and hear one of these flutes actually played. And another interesting thing about tone languages that before we leave it, okay, is that speakers of tone languages seem to have seem to preserve absolute pitch longer than non-tone language speakers. Okay? And of course, language and music share much more than just tones. They share hierarchical structure, as is made clear in this paper by Patel. All these things, of course, are the product of the brain. When did we start knowing something about the brain? Well, it's actually quite recent. And the reason it's quite recent is because for a long time, no dissection of the human body was allowed. It's against various religious practices. So when Leonardo da Vinci drew these pictures of the brain in the 16th century, they were not based on very, very detailed dissections. But it's interesting, as this guy says in this review, Da Vinci actually got quite a few things right. The person who specialized in the brain in the 16th century was a man called Vesalius. And Vesalius, often credited to be the father of anatomy. Okay? Vesalius did beautiful drawings of the human brain. Okay? Here's the base of the brain. Here's this seen from the side. Here it is seen from the top. And anatomically, they seem to be symmetrical upon first glance. But recent study shows they are not symmetrical, either anatomically or functionally. These are the guys in the 19th century that first explored how language and the brain go together, starting from Broca. People with Broca's aphasia, okay, cannot say a full sentence, usually restricted to single syllables with poor intonation. Wernicke's aphasia, just a few decades after Broca made its very important kind of landmark report, people who suffer from Wernicke's aphasia lose their semantics. Okay? They can talk very fluently, beautiful intonation, but a lot of times they're non-words. They're called verbal salads, okay? Neologisms and so on. And Jules Desjardins was the first to notice that even if you have perfect eyesight, nothing wrong with your vision at all, you can't read. You can't even name a single letter. So these are the pioneers. Here's an example of Broca's aphasia. All right, stroke and so on. Lost fluency altogether. Complete control of semantics and pragmatics, okay? But no motor control for speech. Wernicke's aphasia, here's an example. These are both samples from a recent paper in Psychological Review. So this guy says, it just suddenly had a pfeffert. Okay, that's not in a dictionary. And all the pfeffert had gone with it. It even stepped my horn. They took them from Earth, you know. They picked my favorite nine to severed, and now I'm a bin, habed by the stam of Fortman, and so on. Okay? It's a little bit like Jabberwocky being Alice in Wonderland. Okay? It follows the mold of English grammar, but somehow the semantics is lost. And here's the Alexia. Okay? Asked to read an eye chart. Okay? Oscar C. is a retired businessman. He is unable to name any letter. However, he claims to see them perfectly. He instinctively sketches the form of the letters with his hand, but he's nevertheless unable to say any of their names. He compares the A to an easel, the Z to a serpent, P to a buckle, and so on. His incapacity to express himself frightens him. He thinks he's gone mad, since he's well aware that the signs he cannot name are letters. And Desjardins followed up on this by various autopsies, and now we have a much better idea where in the brain this type of language impairment resides. Of course, in the 19th century, people could look at very grossly at the surface, at the cortex, without knowing actually what's going on. It was Santiago Ramon y Cajal who finally put forth the neuron doctrine. Here's Cajal in his kitchen laboratory, Cajal in his senior years, and one of the most famous drawings that Cajal made of one of the hippocampal formations that's still used in modern textbooks in neuroanatomy. And of course, a century of neuroscience gives us a much better idea of what's going on. The neurons communicate with each other chemically across the synapse and electrically along the axon. So it's a dual process, an electrical, chemical. So now we can go back to Broca. Broca was really very wise. He knew at that time people understood so little about the brain and would not be proper for him to actually cut into it. So he preserved them. Before he preserved them, he published this very famous paper in which he says the integrity of the third frontal convolution, perhaps the second, seems indispensable to the exercise of the faculty of articulate language. He couldn't be sure that this is right until it was confirmed by a second patient. So he had two examples clearly matching each other that he wrote this paper and published it, that launched in 1861 and launched this area of research on language and the brain. A friend of mine from Berkeley, Nina Dronkers, found out that Broca actually preserved those two brains. Their museum in Paris. She got hold of the descendants of Paul Broca, got their permission, went back and re-examined those brains. Okay? These are the names of the two patients, Le Borgne and Lelong. And indeed, this is the left hemisphere. Here is the Broca's area. And here's a close-up of Broca's area. Dronkers et al. Published their findings in Brain. And essentially, they did a tremendous amount of MRI analysis, sectioning it horizontally, coronally, sagittally, and so on. And the major conclusion is that it's not just a little hole. It's all over the brain. It's not just the left hemisphere. It's in both hemispheres and so on. Okay? So from the very, very localist view that 19th century scientists like Broca, Wernicke, and so on came up with on where language is, now we have a much better holistic, distributed view of where language is. And of course, we can use these brain imaging techniques on newborn infants. In this paper in PNAS just a couple of years ago, they compared the adult brain, the primary neural circuitry for language, and the newborn brain. And they found that there's a very, very strong resemblance. Infants, of course, can do all sorts of other things which we did not suspect before. Suppose I were a tape recorder and I play to you, tu pi ro go la bu bi da ku pa do ti pa, and so on. And I read it to you for 2 or 3 minutes. Would you be able to tell which are the words? 8-month-old infants can. So it's a very amazing type of statistical learning. And now this knowledge about statistical learning in infants is put to good use in further research. This is a table giving the details over the first 12 months, what kind of linguistic abilities unfold. It's very maturationally locked. Okay, I'll quickly go over a few other topics. I'd like to leave as much time as possible for general discussion. So we have this brain now. How does this brain deal with language? Well, how many languages are there, and how are these languages distributed? If we believe in the out-of-Africa hypothesis, then anatomically modern humans left Africa about 100,000 years ago. A lot of the action actually took place in the last 50,000. Okay? But here's the first chart, first graph that puts forth the out-of-Africa hypothesis on a scientific basis. Becky Kahn was a graduate student working in Alan Wilson's lab, was a biochemist at the University of California. She went and collected a lot of placenta from women after births in Oakland, San Francisco, Berkeley, and so on, about 140 of them. Then she analyzed the mitochondrial DNA in these materials that she collected. Mitochondrial DNA, we know, goes down just the female line, mother to daughter. So it's uniparental. So it's possible to construct a tree. And here's the tree that she constructed. And the amazing thing is that right here at the root, the first branch, are women all of African descent. And this is the basis for the out-of-Africa hypothesis. Many things have been done to confirm this and to refine it. So Cavalli, Sforza, and Feldman, on the basis of this hypothesis, speculated this is the actual migration history of the world, leaving Africa about 100,000 years ago, going to Asia kind of as the spawning ground. Some went to Europe, some down south, some across the Bering Strait, and went all the way down to the tip of South America. So what do we do with all these thousands of languages? This is the birth of linguistics. English jurist was sent from London to go to Calcutta, and he was actually a brilliant student of languages, even though his vocation was that of a jurist. After studying the languages, the liturgical language of India, Sanskrit, he said that this is related to Latin, Greek, Persian, and so on in a systematic way. So you can establish genetic relations among languages in the same way that you can do with organisms. And here's some data from Colin Renfrew, who is an archaeologist at Cambridge. Some low integers. 2 is twi in Germanic, but it's duo, dva in other languages, other Indo-European family. And in Japanese, it's futatsu, obviously very different. 3 starts with a th in the Germanic languages, but starts with a t in the other languages. Again, Japanese is out. So just looking at these two numbers, we can say in Indo-European, there was a D that begins with 2. But in Germanic, the D has gone into a T. And if the word begins with a T in these other languages, in the Germanic languages, it becomes a th. G becomes a K, K becomes an H. D becomes a T, T becomes a th. B becomes a P, P becomes a f. This is one of the great discoveries in the early 19th century. It's called Grimm's Law. It's evidence like this that allows us to say, yes, these two languages are more closely related than those languages, and so on. So 200 years of research. Okay, here's a tree diagram published in Science a few years ago. Here's English. Middle English of Chaucer, Old English of King Alfred, West Germanic, Germanic, leading to the proto-language maybe 8,000 years ago. And even more recently, here's another tree. Here's a tree that's curled around, but it's the same Indo-European tree, and it gives a slightly greater definition on the branching. This was published in Nature Review Genetics a few years back. So the Indo-European that we've been talking about, according to some linguists who see things in a more panoramic perspective, is actually part of a larger family called Eurasiatic, Europe and Asia. And Eurasiatic includes the Altaic languages, which includes Japanese, for instance. Japanese and Korean. Same can be done for Chinese. Okay? So 1, 2, 3, 4, 5, 6, 10 for 华语, for Mandarin. Here it is in Cantonese. Here it is in Shanghai. Here it is in Taiwan, Minnan. Here it is in Japanese, but the Japanese bears a resemblance to the Chinese. Why? I just got through saying Japanese is Altaic. Well, it was borrowed. Okay. Many languages have two sets of numerals, one native, one superimposed by some later language. And Chinese actually belongs to a Sino-Tibetan family, which, according to some linguists, belongs to a still larger family that stretches across the globe like this, called the Dene-Caucasian family, pointing out the languages like Navajo and so on in America are actually distantly related to Chinese. This is something that Edward Sapir said at the beginning of the 19th century, at the beginning of the 20th century. Well, I want to skip over these rather quickly. I want to give us an idea of how diverse languages are. So, for instance, languages, some have a lot of grammar attached to the verb. Some have a lot of grammar attached to the noun. In Italian, for instance, the verb to walk, camminare, okay, has a whole lot of inflectional paradigms depending on person, mood, tense, and things like that. Similarly, the nouns are more complicated than, for instance, a language like Chinese. There's singular and plural, masculine versus feminine. So it's masculine singular, there's the O suffix. Ragazzo means boy. Ragazzi is boys. Ragazza is a girl. Ragazze is girls, and so on. Okay. In Russian, it's even more complicated. Okay. You have 3 numbers, and you have 3 genders, masculine, neuter, and feminine, singular, dual, which applies to 2, 3, 4, and plural, which is 5 or more. So for each of these 9 cells, you have a very different conjugation. You have a very different declension. Here's another language that puts a lot of weight on its nouns. Okay? This is Swahili. We saw in Russian there are 3 classes for nouns. Swahili being one of the Bantu languages, one of the simpler ones, with only 6 classes for nouns instead of 3 in Russian. Other Bantu languages have 8, 9 more. Okay? And each time you pick a noun, like the noun tu here, which is the same tu as in Bantu, which means people, okay? Then you have to accept that this is a class 1 noun. If it's a class 1 noun, if it's a singular, it takes the prefix, not suffix, m. If it's plural, it takes the prefix wa. If you take a noun like basket, then it's kapu. The singular for kapu is ki because it's class 4, and the plural is vi. More than that, once you pick a noun, you're kind of stuck with this noun class sprinkling throughout the sentence. So if you want to say good person, you have to say mzuri mtu. You have to say one good person, you have to say mtu mzuri moja. And this goes with class 1, this goes with class 1. For plural is watu, wazuri, wawiri, wale, wameunguka. And so on. Okay? So complexity is found in different areas in different languages. In this case, the concord system is one of the hardest that I think for a neutral observer to master. In Chinese, on the other hand, they have a classification of nouns which are based on its measure word. So for instance, there's a ge for a general measure word. This is the first measure word that an infant learns when it comes into the language. Then gradually gets refined. Knife takes the type of this measure word. Table takes this. Snake takes this. Flower takes this, and so on. And one comprehensive grammar of Chinese by Y.R. Zhao lists over 80 of such for one class of classifiers. Okay? Again, that's a type of complexity. Instead of saying 2 knives, you have to say 2 ba knives. 2 knives is not a possible construction in Chinese. Next topic I wanted to briefly touch on is that so far we've been talking about trees. Trees deal with only vertical transmission. What about horizontal transmission? The geneticist, Italian geneticist Luca Cavalli Sforza and I talked about this many years back. And I happened at that time just to have readily available a body of vocabularies for 17 Micronesian islands. The Micronesian islands hovering around 7 degrees north above the equator, okay? And we used that vocabulary and constructed this type of a diagram on the basis of his suggestion. The language may differ spatially in the same way that genes do. And of course, horizontal transmission is rampant in China. Here is the province of Sichuan, where a lot of the hot food comes from. And here's a site where they speak a language called Daohua. And here's some example of Daohua. In Mandarin, we would say, 一个骑马的人来了. A man riding a horse came. In Dahua, you would say, 马骑人一个来了. Completely reversed syntax. So here you have an example of Chinese vocabulary grafted onto Tibetan grammar. And recently in Hong Kong, I heard these things in either shops or movies. This one is in a shop. A lady was buying, I think, some kind of a toaster, and she asked, guarantee ga? Guarantee ga? Obviously, guarantee or not guarantee particle. A couple of days ago, we heard about cultural mixing. Language mixing indeed can be extreme. Or in another movie, we heard this, "Sop my area." Here's the sorry. Split apart by what? What are you sorry for? And this says, is it guaranteed? Okay. So the example from the last slide is Chinese word, Tibetan grammar. Here you have English words, but Chinese grammar. Okay. So this type of intermixing is very extensive, and it's important to study them. A very memorable experience I had was that here's Xinjiang. Here is, it was still the Soviet Union then, but now this is called the Republic of Kyrgyzstan. I've heard that a bunch of Chinese in the middle of the Qing dynasty, about 150 years ago, had a revolution against the Manchus. The Manchus won the war, pushed them out, and settled around here. So I went and found them. This was when it was still the Soviet Union, was difficult. And I went to the Academy of Science, made some friends, and they gave me a book. And this book, it says, 回族语言, the language of the 回族. And here's Chinese. And here you have an extensive mixing of languages, of Chinese, of various dialects. You have Russian, you have Kyrgyz, and you have a bunch of other languages. This is a story by Tolstoy, by the way. The limits of my language are the limits of my world. We have such diversity of languages. Do they limit our worlds in different ways? Sapir said, the real world is to a large extent unconsciously built up on the language habits of the group. And the geneticist Nobel laureate François Jacob said we mold our reality just in the same way as we are molded by the vision and our hearing. And it also makes it a unique tool for the development of the imagination, such as talking about absent objects. Actually, several hundred years ago, somebody asked the question, does use and exertion of mental power gradually change the material structure of the brain? Just as we see, for example, that much used muscles become stronger, it is not improbable, though the scalpel cannot easily demonstrate this. Well, I think now we're finally, with brain imaging, better linguistics, better knowledge of linguistic diversity and so on, we can explore this range of questions having to do with what's called the Wolf hypothesis. how different languages shape different brains produce different perceptions produce different behaviors in turn produce different brains. I will not take the time to go over one of the best series of experiments on color vision. The point is, in different languages, you divide up the color spectrum in different ways. So we would call this all the same color. We would call this all the same color. But in Korean, these are two different names. In Russian, these are two different names. And there's a whole series of studies, especially led by my good friend Paul Kay, going back many years, that show that your non-linguistic reaction to color in terms of discrimination, okay, is conditioned by the language you speak, by the words at your disposal. Non-linguistic, just reaction time of yes or no difference. Galileo, I like to spend maybe 5 minutes on writing. Okay. Galileo said, of all the other stupendous inventions, what sublimity of mind must have been his, who conceived how to communicate his most secret thoughts to any other person, though very far distant, either in time or place, and with no greater difficulty than the various arrangements of 24 little signs upon paper. Let this be the seal of all the admirable inventions of man. He's talking about the alphabet, of course. Here's an example of the alphabet. Here's Le Petit Prince, translated, starting from French, translated into English, into Italian, into Russian, and also into Chinese, into Japanese. The question is the alphabet the ultimate triumph for writing systems? Or are there experiments that can be done to evaluate various writing systems for various languages to see the best match? So obviously, a good contender would be Chinese. Okay? People sometimes speak of Chinese as though it's mostly ideographic or logographic or something like that, but that's not true. Over 80% of the Chinese characters, over 80% are phonograms. Phonogram means part of it has to do with the meaning, part of it having to do with the sound. The meaning part we call the radical, 部首, okay? So here the 部首 can be on the left, meaning something like water. On the left, meaning something like wood. This is ocean. This is pine tree. So this part tells you it's something to do with water. This part tells you that it's pronounced something like yang. And in fact, it is pronounced yang. This is a phonogram. Something like 80% of Chinese writing is made up like this. Of course, you have to be able to decide which part is the meaning part, which part is the sound part. But the nice part about this is that the meaning part comes from a very small inventory. And if you remember these 200 radicals or so, most of the time you can very easily look up the character in the dictionary. Here I illustrate it occurring in different positions. The red is the radical. So I think this is a good contender for writing system, because what is it that we want when we read? Ultimately, via the sound, we want to get at the meaning. So we're looking for the coupling between sound and meaning. And this writing system is the only one that gives you both simultaneously. It makes that match for you. Another difference is that if you look at an English word, especially a long word, 10, 12, 15 letters, it takes up a huge amount of your visual angle. Here, you have much greater graphic density, but at the same time, it consumes much less visual angle. And if you scan your eye across a page, your immediate memory has a ceiling. Okay? If you have to scan a very, very long line, okay, the information intake gets compromised. I'm not saying, not recommending this for the world, okay? I'm just saying it has certain merits which have not been considered before when a man like Galileo, okay, sounded the triumph note of the alphabet. I think it depends on the language, and I think there are various considerations. Alan was saying that Hong Kong attracted me there because of the food. Oh, the food is really heavenly, okay? And some while back, a friend of mine came and said, you know, there's a restaurant in Kowloon, okay, which has some kind of foreign language writing. Can you tell me what language that is next time you go there? So I went there and I looked and I looked. It doesn't look like anything I know. You know, Chinese has many, many different scripts. Mongols invented a script, Shishas invented a script, Khitans invented a script. There are many, many scripts. But this doesn't remind me of any of the scripts that I've scanned. Then suddenly it dawned on me. This is pinyin. This is X, U, N. Y, U. 熏鱼. This is G, U, O. T, I, E. 锅贴. And here's my favorite, which I had at Canteen 1. Okay? Go to Canteen 1, you can get 小笼包. And this is how you write 小笼包. X, I, A, O. Writing is such an important thing in the modern world. Okay? We must explore all sorts of possible matches and possible permutations for different languages. Okay, here's my last point. A few years ago, I came across a paper in BBS, Behavioral and Brain Sciences, that's entitled The Weirdest People in the World. What do they mean by weird? Well, it turns out it stands for Western, educated, industrialized, rich, and democratic. Why do they say that? Why do they want to highlight this? They want to make the point that a lot of the research done in medicine, done in psychology, done in many aspects of behavior are based on 12% of the world's population. And that's these weird people. Okay? I think it's great that the vanguard is being made in such research. But for certain conclusions, it's really important to watch our sampling here. So later on, I guess nature invited them to write a shorter one called Most People Are Not Weird. And this actually recapitulates one of the points that I made early on. Languages are not all the same either. Languages are not just somewhat deformed varieties of English. languages, each one in its own right has its own logic, has its own structure, and should be studied as such. So their paper was called The Myth of Language Universals, Language Diversity and Its Importance for Cognitive Science. And I'm really happy that NTU linguists, are all very much aware of the danger of sampling too narrowly and looking at languages with a wide perspective. So this is my last slide. Language is the single most defining feature of our species and a primary vehicle for our cultures. It should be investigated with respect to its rich diversity and multilingualism, building on the foundations of evolution theory and a multidisciplinary perspective of complexity science. There, I ended with the right words.
Maybe we better stay there. We still have about 10 minutes for discussion. Now I see the connection between writing musicals and doing research on languages. And also, we're not that weird, so please come back and do research at NTU. Please, any comments, questions from the audience?
Thank you very much. It was a brilliant, brilliant presentation. Just a small question. When I started doing science, I started off in nuclear physics, and I moved to psychology, and I'm now in a bit of psychology and language. One of the things that I was taught was I should shave with Occam's razor as much as I can. The law of parsimony. Where does that fit in your complexity science? I'm sorry I missed the last 2 days. I missed some brilliant things.
I'm very sorry. Could you repeat your question? I missed an important verb there.
The important question was, as a scientist, I was taught I should go for the law of parsimony. However complex things are, and I think you've demonstrated very well today how languages, their roots, where people come from, Africa, all those kinds of things. And actually, we go down to very simple roots. So I'm just wondering whether, even though I work in diversity issues, whether we're just making mountains out of molehills by talking about complexity science. Sorry if I wasn't here for the last 2 days.
I think that's a very deep question. If I had to go and master all of the disciplines that I've alluded to, I'd be at least 300 years old. So I think somebody said within the last 2 or 3 days that an important key to a multidisciplinary perspective is collaboration. Okay? So when I had a genetics question, I went to Cavalli Sforza. When I had a statistics question, I went to my friend David Friedman, who's a mathematician at Berkeley, and so on. And we learned from each other, and we wrote together. I think the key is not to say, I'm going to be an X in X discipline, but rather, what is the question I want to ask? Once you have the question, you go shopping in various disciplines. Maybe this guy can provide me with the facility, this guy can provide me with a method, this guy can tell me more about the history, and so on. And collaboration results, and you come up with a paper that reveals all sorts of hidden connections. So we want to simplify. Parsimony is certainly a primary desideratum for science. But I think it was Einstein who said, make things as simple as possible, but no simpler. But where do you draw the line? I think you draw the line after you know what is the question that you want to ask and what bodies of knowledge you want to tap.
Yingyi?
Thank you, Professor Wang. I really enjoyed your talk. And I have a question about cultural mixing or language mixing. I'm very impressed by the pictures you show, the Gaolongtang, restaurants. I think it's very creative. And so I grew up in Hong Kong, so Hong Kong people are very creative. We use a lot of new words every day, and then we do a lot of code switching as well. But all these are kind of colloquial, very informal. So in Cantonese or Chinese language, it doesn't seem there is a formal way of including or absorbing languages from another culture. Like, for example, in Japanese, they have gailaigo, which is they borrow the pronunciation from Spanish, from French, from English, and then make it as their word. And that absorption is quite rapidly. So I don't know about other language, whether other language have that mechanism as well. So I'm just trying to see whether there are, even in languages, there are ways that allows you to absorb another culture or another language and make it one of your own.
All languages borrow from other languages. But I think you pointed out very correctly that they differ to the extent that they borrow. If you compare Japanese with Chinese, Japanese borrowed extensively. I have a friend called Matt Shibatani, who has a book on the Japanese, and he pulled out layer after layer of vocabulary from English, from Chinese, from all sorts of languages. English is another one that has borrowed extensively. Something like 50% of English vocabulary is from Romance languages. Chinese, on the other hand, although it has borrowed from other languages, has been a lot more resistant. I shouldn't say borrowing as though it's just one type of activity. You could borrow in two ways. You could borrow by translating the sound. You could borrow by translating the meaning. Chinese does a lot of the second type of borrowing, but very little of the first type of borrowing. So you could borrow skyscraper, skyscraper, or you could say it's mo tian lou. Okay. As to why one language prefers this, another language prefers that, and why they differ in the extents they do this, I think that's something for an expert on culture mixing. I think it goes beyond language.
Yeah.
Back, please. While the mic is being transported, is it okay if I ask a question that you can answer later as well?
Sure.
One of the issues I'm particularly concerned with is the disappearance of many languages. Some may call them dialects. And given your discussion, I'm just wondering, how would the disappearance of languages eventually impact on human cognitive behavior and cultural intelligence in general? But I shouldn't monopolize. There's a question at the back.
Hi, thank you for your talk. So I just want to ask, so a lot of languages evolve, I guess, through convenience. So like what you showed, like guarantee, or like Singlish, which is a mixed pot of all the languages that we have here. It's just we take the most convenient parts and we form a new language like Singlish. So I was just wondering why Swahili, I think it was, and that had the me and the ki, and why would they keep that for every word if you can already tell what it needs to be from the first word? Like, why would a culture keep such a complex language when it's just easier to get rid of some of it?
That's something I often wonder myself. A very famous Russian linguist called Jakobson said that the essential difference among languages is what you have to say whether you want to or not. Tenses like that, numbers like that. If I want to say today, why do I have to put an S at the end? I've already told you to. Similarly for the Bantu languages, it's a requirement of the language that holds sentences together. so that if you mix two sentences, there's enough redundancy for you to do error correction. But why one language has one particular type of redundancy or constraints on the speaker, another language has a different set, I think a lot of that is due to the history of the development of the language. Okay. I know that the Concord system has been around for centuries. On the other hand, the classifier system that I mentioned for Chinese is even older. That started in Weijing Nanbeichao, which is something like 1,500, 600 years ago. Okay. So some of these things, excess baggage, do get lost. But when they get lost, somehow, oftentimes, others creep in. Charles Hockett, that I referred to earlier, once made the offhand remark saying that all languages are about 50% redundant. Okay? I don't know how to measure this, but I think it contains the germ of truth, that different languages force you to speak at different points, providing information whether you want to provide it or not.
You probably will have to ask Bill more questions over coffee. But at this point, maybe one final question. Sorry about that.
Just a comment from what you just said. Peter Drucker said, in talking about language, it's for communication. And at the moment, we are concerned about the decay of some languages and the bastardization and all that. But his point that communication takes place only when the person receiving the communication understands what you say. And it doesn't matter how you say it, whether you say today or 2 days or do a hurry or whatever it is. It's whether you can understand. It doesn't matter whether it's grammatically correct, whether it's pronounced correctly. And I think if we look at it from that perspective, it perhaps answers that question which this gentleman asked as well, about where do you draw the line? If communication is the essence, then perhaps that should be guiding language itself. Thank you.
Well, very briefly, I think that's a very interesting question. In Hong Kong, their newspapers are having very, very critical essays all the time saying that the language is going to the dogs because the young people don't know how to pronounce things anymore. So instead of saying nay for you, they say lei, and so on. Okay? But that's just the natural course of language evolution. But the deeper question that you ask is, when you talk to somebody, he not only understands your words and how they were put together syntactically, he also draws a lot of other information about you. Like, are you from Sydney or are you from Benares? Are you a professor or are you a cab driver? All sorts of other things, okay? So linguists call these different registers, and a subdiscipline of linguistics that studies those things is called pragmatics, okay? I think so, although you may be lexically correct, grammatically correct, you may be speaking on the wrong register and not producing the effect that you want, even though you got the meaning across.
Can you answer the question of the chairman? I have to legitimize you.
Sure. This is an issue that I'm very concerned about. Alan said I came to Hong Kong because of the good food. That's part of it. But I came to Hong Kong because I realized that languages and dialects are dying by the day in this part of the world. I took many field trips to Guangxi, to Yunnan, to Guizhou, and so on, and see what's going on. Why are these languages dying? And they tell me, you pave another road to this village and 2 more languages will die. It's all part of the modernization process. So for instance, if you go to Pumi family, say, why don't you teach your kids to speak Pumi? Why don't you speak Pumi at home? That's your native language, and it has all sorts of beautiful aspects like each dialect does. They say, no, what kind of a job would he get? If he has time to learn another language, I want him to learn Mandarin. And if he still has time, certainly he ought to learn English. Pumi just doesn't cut the ice anymore. And it's not only with minority languages, it's happening with dialects, okay? Quite often people from Shanghai coming to study with me when I was at Berkeley don't speak Shanghainese anymore. They speak Putonghua at home. It's very difficult to put in. Thank you very much, Alan, for your gracious words. I will try to live up to them. I also like to thank Jan for inviting me to this intellectual banquet. What conference is there, that you can hear about galaxies and bacteria within a few hours of each other? I'm sure I've learned a tremendous amount. I'm not quite sure yet what I learned. That'll take some digestion and reflection, but it certainly has been extremely stimulating. Monday morning, there was a very enjoyable session exploring the hidden connections behind this conference. So let me just tell you very briefly how this outlier node gets connected to this very important network. So I see John sitting there. It was in the early 1960s. Okay, John Holland and I were freshly minted PhDs, and we co-taught a course, what probably is kind of a very early version of complexity science. It was called communication science. After that, I went to Berkeley, and for something like 3 decades, we lost contact. Then one day I was wandering around a bookstore on Telegraph Avenue in Berkeley, and I saw a book on the shelf there saying emergence. I've always been interested in the evolution of language, so a title like that certainly meant something to me. I took it down and looked, and the author was John H. Holland, and that rang a loud bell. So one thing led to another. John came to Hong Kong and spent some time with us, and it's partly a legacy from John's visit that we now have in Hong Kong something also in this general area. So the connection has been from Ann Arbor to Berkeley to Hong Kong to Singapore today. And John's legacy has been a new center established just a couple of months ago at the Chinese University of Hong Kong called Joint Research Center of Language and Human Complexity. It's distinctive in that it's collaborative among 3 universities: Chinese University, Peking University, and University System of Taiwan. Right? Unlike Hong Kong is always trying to catch up with Singapore, okay? And in this case, we don't dare to be this ambitious, okay? Martin Rees talked about very, very, very small things to very, very, very big things. And in the middle, of course, is us. So we will focus on human complexity, specifically in the area of language. And I hope that our interactions will increase as the research gets more and more results. So I like to begin with a picture. Yeah. I don't know very much about art, but I liked this picture, especially when somebody called to my attention what's scribbled over there in that corner. Here's a blow up. You can probably read this now. It's Gauguin asking 3 questions. Where do we come from? What are we? Notice he didn't say, who are we? What are we? What kind of being are we? And where are we going? So these fundamental questions require a multidisciplinary perspective, such as in complexity theory and in evolution theory. We share a very long evolutionary history with primates, especially the chimpanzees, our closest. This now works, huh? So I'm no longer tethered here. Especially the chimpanzee, our closest living relatives. Despite striking similarities, language has not emerged among chimpanzees. And they cannot be numbered on the kind of cultural loss that this involves. But I firmly believe that what is a culture? A culture has to have a vehicle to put it in. What is that vehicle? It's that language. Once you lose the language, you lose that vehicle for containing, systematizing that culture. And I think that's a loss of the human heritage.